This video is about polygons. You can use your notes packets to follow along and fill these in. There is one mistake in your notes packets though. There's a shape that's in the box that should be over to the side. There's actually 3 characteristics to making a polygon. So the 3 characteristics of being a polygon, the first one is it has to be a closed plane figure, which means all of the sides connect. It has to have 3 or more sides, and it can only have one included area. So if it overlaps or does anything like that, so for instance if you have something that looks like that, those count as 2 areas, so that would not be a polygon. If it has curves or if it doesn't connect, it does something like that where there's this opening, that would not be considered a polygon. All right. All of these over here, except the circles because they have curves, would be polygons of different sizes, different numbers of sides. So if you look in your notes, you have these pictures. We have this one, is it a polygon? All right, this one would be no because it has curves to it. This one would be yes. All right, it's all one enclosed area, all straight sides. This one would be no because it has 1, 2, 3, 4, 5, 6 enclosed areas, not just one. And then mine is missing a picture that you guys have that's over in your box that looks something like this. And this one would be yes. So this one would be no because of the curves. This one would be yes. This one would be no. And this one would also be yes. It just has one enclosed area in here in the middle, so even though it wraps around, all the sides are straight. So it would be in fact a polygon. Alright, then we have to identify our different polygons based on the number of sides it has. So if it has 3 sides, it's called a triangle. 4 sides, and a lot of you are probably thinking square, rectangle, things like that. Those are types of, but the overall category would be quadrilateral. Squares, rectangles, parallelograms are all quadrilaterals, but they are specific types. The overall 4 meaning, quad meaning 4. 5 sides, there's a big one in Washington, D.C. called the Pentagon because it is a 5-sided building. 6 sides is a hexagon. 7 sides, a heptagon. 8 sides, an octopus has 8 legs. An octagon has 8 sides. 9 sides is called a nonagon, not a ninagon, but a nonagon. 10 is a decagon. If you think about the metric system, deca, that prefix means 10. You don't have this one, but an 11-sided is called a hendecagon, and 12 is a dodecagon. 13, a triskidecagon. Once we get above those, we usually call them a 45-sided figure and a 102-sided figure do actually have names. And if you want a couple of bonus points, if you're watching this and you want to take the time to look up what the actual technical name of a 45-sided polygon is and a 102-sided polygon, you can put that information onto something and bring it to me in class tomorrow. Turn it in for a few extra bonus points. And then just tell me in general, how do you name polygons? Like, where do these names come from? So the 45-sided shape has an actual name. How is it named? How do you make the names of all of the other shapes that we're not talking about right now? Bring that to me in class tomorrow, and you can have up to 5 bonus points depending on how much information you include in there. So I'm not going to tell you what a 45-sided figure is or a 102-sided figure. You're going to find that out for me. But for right now, we're just going to call them a 45gon. But for the bonus points, I want their actual names, and a 102gon. labeling a polygon, so not naming them, so not based on how many sides it has, we have to pick a vertex to start at. Doesn't make any difference which one. So I'm going to start at vertex P over here. And since it's a pentagon, we're going to start with the abbreviation pent. And then I'm going to just pick any vertex, and I could start with whatever one I want to. And then I'm just going to go around the shape in order. And I can go, again, I could go either direction. So there's more than one way to label this one. But mine, the way I have it set up, would be P, Q, R, S, T. All right, we could have picked a different starting point. We could have started over here at S, and we could have gone S, R, Q, P, T as well. So that would be another name for the same one. I just started somewhere else. So S, R, Q, P, T. Just make sure once you pick a direction, you keep going in order. Don't bounce back and forth. We don't want to go across the polygon. We just want to keep going around the outside of it. Then we have the terms convex and concave polygons. So the difference between the two, a convex polygon has all of our vertices pointing outward. So that would be convex. Whereas a concave, we have one side that has pointed in. We have one of those, what we call reflex angles inside it. Reflex angles pointing in. So these would all be convex. Everything points out. And then down here we would have concave. We have our reflex angle here, we have our reflex angle here, and we have several reflex angles in this one. We have 4 of them. So convex, no reflex angles, everything points out. So no reflex angles on the inside, interior. Concave has at least one reflex angle on the inside. So if we were looking at these 3 examples that you have in your notes, by sides, it has 1, 2, 3, 4, 5, 6 sides, and these don't necessarily have to be equal. So this would be, they're all pointing out, so this would be a convex hexagon. For over number 8, all right, we have these little reflex angles here, so this one would be concave, and it would be a concave, and then just pick a starting point, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, so that would be a dodecagon. And number 9, again, we have that reflex angle here, so this would also be concave. And again, if we pick a starting spot, 1, 2, 3, 4, 5, 6, 7, 7 sides. So that would be a heptagon. So concave has at least one reflex angle inside the shape. Convex does not. And then our last few terms, equilateral. If we have equilateral shapes, that means all of the sides are congruent. So equilateral, all congruent sides. Equiangular, all congruent angles. And so a square would be equilateral and equiangular. A rectangle would just be equilateral. Rectangles would have equal angles, but not, I'm sorry, this would be equal angular. And equilateral would be a square. It would actually be both, and if it is both, it is equilateral and equiangular is the definition for regular. So equilateral, all congruent sides. Equiangular, all congruent angles. And regular, equilateral, and equiangular. To be equal, or to be regular, you can only have convex shapes. So equilateral shape, you could have a concave one if we can make it where all our sides are the same. As long as these would all be the sides, that would be equilateral but not equiangular. All right, that rectangle equiangular, and regular would be both.